Greetings, Scratchers, and once again, welcome to an episode of Programming in Scratch. As always, this is intended for my Redlands Conservatory class, but absolutely everybody is welcome to follow along. In this lesson, we're going to do something which seemed really simple and proved to be very challenging, but it covers a few different topics that I think you'll find useful, including, once again, a little bit of 3D animation and setting up a time base and some variables in Scratch. We're also going to very briefly cover taking your Scratch programs and making them executable files, which can run not only on anyone's computer who doesn't have Scratch and can be passed around without anybody seeing your code, but can even be changed into a Java jar file and possibly run on a phone. So looking at the program here, this is a basic metronome project, a metronome being a device which just keeps a steady beat while you're playing a musical instrument. So the conservatory where I work teaches music, and we thought this would be a wonderful calling card. So let's fire up the metronome, and I will click the green flag. You can hear that clicking, which is sampled from a real metronome, actually a classic. And currently, the quarter note here shows the value in beats per minute that the metronome is keeping. So if you're playing a slow song, a hip-hop song might be somewhere around 100 beats per minute. Slow rock and roll might be 90 beats per minute. And the far extreme of that is 30 beats per minute. And I'll show you some of the challenges we encountered in Scratch. So I'm going to click on the up arrow. We're increasing to 40, 60. And as you can see, the metronome increases in speed as we go and keeps a very steady tempo. Now this is a defect in Scratch 1.4. And if you listen to that clicking, as we get up to the higher speeds, it becomes a little less steady. When you import this project into Scratch 2.0, you will find that your metronome is absolutely perfectly steady. And it's only here in Scratch 1.4 that we found that defect. Now, I'm actually assembling this in the Build Your Own Blocks, which is a takeoff based on MIT's Scratch. The reason that I downloaded the Build Your Own Blocks program, which you can find by just Googling Build Your Own Blocks, is that it has a feature here under Share where you can compile your project. And that's the feature that I mentioned right at the beginning that allows you to take any program you write in Scratch and change it into an executable file that'll run on other computers, and with one more step will run on people's phones. So all you have to do is take any Scratch 1.4 project, it doesn't work with 2.0 yet, and bring it into Build Your Own Blocks, and then you can export it as an executable file. It's actually just that simple, and it works absolutely great. Changing it over to a Java jar file is not quite as reliable. So some programs work, it depends on the graphics. A few of them don't work. So the other thing that I will recommend very, very quickly is to assemble your programs if you're doing 1.4 in the Scratch utility. Don't assemble them in the Build Your Own Blocks. There are some pitfalls that you can run into if you do that. Plus, there is no going back from Build Your Own Blocks. Once you've saved in this format, then you're stuck with Build Your Own Blocks, and that may not be what you want if you're uploading and downloading from the Scratch website. So just use this program when you're intending to port your final version of your program over to an executable file. So here we go. You can pause the video at any time if you want to take a look at this. Usually I assemble these a step at a time, but so that we can do this as quickly as possible, I'm just going to actually step through it, and you can, as I said, you can freeze the video if you want to copy this exact thing. Now the costumes here, you can use any animation costumes that you want for your moving metronome, and all of these costumes of my little metronome that I put up will be available on the website given at the end of the video, so that if you want to download them for your own project, you can use the exact same metronome we used. But you're not stuck with the same metronome. You can use any animation that you would care to. The same is true also for the sound. I have a metronome click sound. You can get that just about anywhere. You can get that off of Google. The particular one that I captured will be available for you on the website. So let's take a look at the program, because there are a couple of quick little tricks. So our first sprite is actually the metronome itself, and I have a variable which is going to be beats per minute. Now under variables, there are actually two variables. We have beats per minute and we have select. Select is going to be what is going to contain the variable which tells us what our metronome is going to be set to as far as tempo. And then beats per minute is the actual fractional number that, in this case, Build Your Own Blocks or Scratch is going to use to create a delay so that we get the right speed in our metronome. And just to sort of jump around a very, very small amount here, I thought I would show you how I was able to calculate what the right beats are for the metronome. And I did this in a little bit of a backwards way. I simply downloaded a music program. So here's an ordinary music program, which I just brought up in a window, which is sizable. So I sized it to fit the screen here for you. And what you can do in most music programs is you can click on the metronome, and you will find that there is a click tempo button. So now when we click this tempo button, it's going to calculate the tempo. So let's go ahead, we'll run our metronome. Right now it says 130 beats a minute. Let's go ahead and we'll bring that down. So that's 30, and we'll come back to our music program, and then we'll tap along with it, which is actually a little hard to do. It's usually good if you count in between 1, 2, 3, 4, 1, 2. So as you can see, our tempo is about 30 beats per minute just by clicking our tempo bar. So that's a great trick if you're building a metronome. You can just load a music program, and then you can find your beats per minute. And the delay is set here at beats per minute. Our delay starts out at 0.05. So let me go ahead and do, now ordinarily for cleanness, we would not have our beats per minute shown as a variable. But 0.3, a delay of 0.3 creates about what we were looking for, about 30 beats per minute. So let's see, it started at 0.05, so it actually started out to have a little bit longer delay than what I was specifying there. So the basic way that this works is we have a forever loop, and here is one of the first tricks if you want to do something like a metronome or anything in your gaming where you need a very steady tempo. You don't want the program to wait around for your graphics to be displayed. So we use the broadcast command. And we simply start off by saying broadcast a click, which brings it over here to when I receive click, play the sound of a metronome click. So that way it broadcasts over here, produces the click at the same time as we are stepping through our steps in the animation. And the animation changes its speed based on that beats per minute variable. So we broadcast a click, then it goes ahead and it says wait for this fraction of a second, display your first step of the animation, wait for the same fraction of a second, display the next step of your animation. Once the metronome has moved, the hand of the metronome has moved all the way to the right, we encounter our next click, because we'll have a click at either side. So it broadcasts the click again, and then we run those metronome steps, the graphic steps in reverse. Metronome 6 position, metronome 5 position, 4, 3, 2, 1. So here's 1, 2, 3, 4, 5, and then 6, 5, 4, 3, 2, 1. So it runs the hand to the right, runs the hand to the left. Now I'll go ahead and run it and change tempo so you can watch up here where it's showing beats per minute. Maybe I can make that a little larger. Yeah, that's good. And you can see the different numbers with Scratch 1.4 that correspond to different beats per minute. One of the many defects, so one of the defect in 1.4 is that the tempo is not steady at the highest tempos, which is a little bit frustrating, but it's good to know that about the program. And it's also a defect which carried over into Build Your Own Blocks and carries over into the executable. But if you load this into Scratch 2.0, they fixed that problem in 2.0. The other thing is that when we can only go up in Scratch 1.4, this is a big defect, in tenths when we are specifying up and down in tenths. So by going up and down in tenths, there are points where we jump over certain tempos that we might have liked to have. It's still good because we covered all the major rock and roll, hip hop, and trance type tempos. But watch this, as we go up, our beats per minute is going to change. 0.22 delay gives us 40 beats. 0.13 delay gives us 60 beats. 0.09 gives us 80. 0.07 is 90 beats. 0.06 is 100. And 0.05 is 130. And that's as fast as our metronome actually will go in Scratch 1.4. So the reason I wanted to step through those specific numbers is so if you are creating a metronome and you don't want to necessarily use a music program to dial it all in, you've actually got the beats per second there. You can write those numbers down, review that part of the video. So as you can see, our main sprite is nothing more than an animation sequence with 2 clicks and a broadcast. That is it. Going over to our up and down arrows, this is a great thing to learn that a few of my students, I've seen them do it, and a few of the other students weren't quite sure how to do. And that is, if you hover over something with a mouse and you click on it, how do you know that the button has been pressed? And a lot of people were confused because they were using the mouse down command. The mouse down command will detect any time that your click button is clicked on the mouse, but it doesn't know if the mouse is in a certain position. So you simply say mouse down, and if your sprite, in this case sprite 2, our up arrow, is touching mouse pointer. You go ahead and you go from your operators there and you select an AND statement, and you go from control and you select your if statement, and then from sensing you will select your mouse down and your touch. And that will allow you, with this and a forever loop, as you can see, it will allow you to create buttons which are clickable by the mouse. And you could even have that sprite change so the button looked like it was depressed. It would be kind of a good thing to do. And the only other trick with that is, as soon as the button is pressed, you do want to go ahead and add in a slight delay. In this case, it waits 0.5 seconds, half of a second, because otherwise when you click with the mouse, you'll get several bounces. It'll be as if you clicked it 10 times in a row because it is traveling through this loop very, very quickly. So add a little delay afterwards. And this little piece of code, again, you can pause the video, is how you can do a button press when you are in Scratch. The final thing here is our notes, which is each time a button is pressed on the sprite screen, it changes our selection by 1. So if we press the up arrow, it goes up 1, and we have here put our values that are correct for our metronome that we just determined using the music program. So when I click up, it's going to go towards, or click down, I'm going to go 1, or up, I'm sorry, up 1, 2, 3, 4, 5 in selections, and it is going to assign beats per minute to that fractional value. As I said, we didn't show the fractional value. You know, I'm getting the feeling that this video seems very slightly confusing in the way that I'm explaining it, when it's actually very simple. That's so often the case. As you can see, this really is the same if statement over and over again, just reading what our selection is. So my advice would definitely be, you can download this program from the web page, get a really quick look at it. You can download it also from the Scratch page. That information will all be available from the web page at the end. And you can obviously freeze this video at any point. Reproducing this is extremely simple. You've just got these 4 little snippets of code, which are all simply a repeat of the last. So you've got your if statement repeated 7 times. And in this case, you have your animation cycle, which is really only 4 frames, which is just repeated twice, once forward and once backward. And there's nothing more to creating a metronome that it covers steadiness, covers the clicking of the buttons, covers a little bit of 3D animation, and it creates something very useful, which you can then save, that will operate on a phone or a computer anyway. So I hope you guys dug this lesson. Like I said, I was trying to think of a simple way to explain it, and it was more complicated to create than I thought, because all these little tricks were very necessary to get the thing to work, and it ended up being more complicated to explain than I thought. So I apologize for that, but I am confident that you can figure it out.